Welcome to this Alan Talks Tech video. If you'd like additional information on my technology videos, please visit my wiki at alantestwiki.pbworks.com. Now let's take a look at what many believe is going to be the next step in network functions virtualization, or NFV. Of course, we are all familiar with shipping containers. These have been used for many years as a very efficient and standard means of shipping our goods all over the planet. A few years ago, when I was giving presentations on how data centers were being put together, I described one novel concept where shipping containers were pre-configured with all the hardware required to build a data center. In fact, each container was a mini data center in its own right. All that was required was for the container to be hooked up to power, cooling, and communications, and the system was ready to go. Multiple containers could simply be racked and stacked to create very large data centers, such as this Microsoft data center in North Lake, Illinois. Today, we are using containers again to help build the data center, but these are software containers, not physical shipping containers. Each container is very much like a virtual machine, containing the applications, OS requirements, and all of the operating dependencies. So let's take a look at how virtual machines and containers stack up alongside each other. VMs require a physical server or metal to run on. They also require a hypervisor. The VMs run on top of the hypervisor. Each VM will then need an operating system to support the applications. On the other hand, containers only need the physical server or metal and one instance of an operating system. We do not need to load an operating system for each container as we would for a virtual machine. The container does not need a VM, as each container is sharing the common OS kernel. Overall, the containers are much more lightweight, as only one operating system, typically a very stripped down Linux operating system, utilizing a system such as Core OS. In addition, as no VM is required, far fewer system resources are needed, and the container, along with its applications, will deploy much more rapidly. The OS is already running. As a rule of thumb, many people believe that up to 6 containers, or 6 times as many containers, may be run on any given platform or metal compared to virtual machines. Docker is built on top of Linux containers, or LXC, and adds image management and deployment assistance for virtualizing applications. Docker provides for automation and rapid provisioning of Linux container groups without requiring a virtual machine. Docker provides an API, an applications programmable interface, that extends the functionality of LXC, or Linux containers, for building platform as a service offerings. Docker today is one of the most popular methods for building, running, managing, and distributing containers. There are other packages available for helping you build a container, but as I said, by far Docker is way ahead of most of the other competing systems. Let's take a look at how you can build and share a container. Firstly, Docker is a client-server application. Building a container to run an application is a little like baking a cake. First, we need to start with a recipe. This is called the Docker file. The Docker file is the default name given to the file that Docker will use to build the image. The image, in turn, will then provide everything that is required to run the container. The image may be large, but the actual running container holding the application and its dependencies may be very light. Only the required components or dependencies from the image will be used to run the container. Remember, the basic OS is already running and will be used by the container. This is one of the key reasons that containers are so fast to spin up. Containers do not need to start a relatively complex VM and then wait for the OS to boot up. So when building a Docker file, for example to run an Apache server, you would add the Apache code or tell the file where to get the code from, add some information on where to get Ubuntu from, add your HTML files or point to where the HTML files are. Then using your Docker client, you can tell the Docker host to build the image. You can then run the image as a container. If you're happy with the image, you can then push the image up into the Docker registry. As I said, Docker contains two components. The daemon runs on a host machine and does the heavy lifting of building, running, and distributing Docker containers. The client is a Docker binary that accepts commands from the user and communicates back and forth with the daemon. For many of us, when we're building a container, we'll often be using the same PC, so the client and the host will be all residing on the same machine. But it's also possible, and it gives us a lot of flexibility, that the daemon can run up in the cloud. So from my PC I can run the client, but I could build the container, build the images up in the cloud. And of course I can store those images which are used to build the containers up in the Docker registry, which is effectively up in the cloud. Using the Docker registry to build your system. Once you've built all of your containers with all of the required applications, each container can be a separate application. All of the containers or applications can be stored in the registry and pulled down and deployed on our server as required. Of course, others may also share these containers with their pre-configured applications and dependencies, making containers very portable across different operating environments. The registry can either be a public or private registry, either on the Docker cloud or on a private corporate server. Thank you for watching this Alan Talks Tech video. I hope you enjoyed it. If you'd like to get more information on my technology videos with additional material, you can visit my wiki at alantestwiki.pbworks.com. Once again, thanks for viewing.